Okay, so it's been many months since our last TrackerSled video. In the intervening months, TrackerSled became a finalist in the Solar Prize. And now what you're seeing here is the first step to building a full-scale prototype. If you recall the much smaller prototype, many of the components look familiar, but scaled up at this point. So we're going to do a quick walk around. First, to discuss where is the TrackerSled now. It's at Granner Farm in Three Oaks, Michigan. And the location, as you can see, is right on the grid here. But first round, we'll be connecting to a grain dryer that you'll see here as the camera pans over. You can see the electrical service in the distance there. So all the 11,200 kilowatts here, or watts, will be generating energy to drive that grain dryer. So Granner Farm is a 400-acre farm that's growing. It's all organic. They use these regenerative techniques. So the purpose of demonstrating it here is an on-ramp to discussing the prospects of building solar farms for distribution co-ops throughout the U.S. So this is a first step of a long journey. So let's do just a quick walk around and we'll discuss the details here of the full-scale TrackerSled. So the first obvious difference is actually the pontoon skis. If you recall the last generation, they were also high-density polyethylene, but very thin shell and corrugated. This iteration actually uses very thick-walled HDP pipe. Again, the same material, but obviously extruded as a round pipe. So clearly the geometry here will be friendly to preventing compaction of the soil. The wall of this is 3/4 of an inch thick. So if you look at these welded brackets here, these are an inch thick. So you can imagine this is just 75% of this thickness through the entire wall of this pipe. So the idea is that all the materials on the TrackerSled are readily recyclable, including this HDPE. Of course, the U.S. only recycles perhaps 5 to 10% of the plastics in the waste stream in the U.S., but this is a very easily recyclable material. It's also a thermoplastic, right? So it's like nacho cheese versus thermosets, which are like scrambled eggs, right? You can keep remelting the nacho cheese. In a similar way, HDPE can be welded. So these brackets, which occur every 4 feet along this 42-foot long pontoon ski, these are all welded. If perhaps, while we're sliding the sled over its 25, 30-year life, it was actually to hit a rock or say a steel stake in the ground and we were to get an opening here. Again, any sort of repair that would be needed to make would be straight, same material, just welded in place. So really when we look at this, this is all about durability, long life, and resilience in many different cases here. The other thing we'll look at is, if you followed the previous videos, is just the geometry of the end, right? Because these sleds are meant to be pulled through a field. And we saw last time that we had issues with plowing into the earth, right? So clearly this faceted end solves those problems for us. What you're seeing here is actually a product that is made as a flotation for docks, floating docks, that we've repurposed here. Now, clearly the TrackerSled could float, so in that way it's amphibious, but its natural habitat is clearly on the ground here in the fields, and we will fill this with ballast, meaning water, treated water, so it doesn't freeze. But this detail is used frequently on floating docks to abate the wave action as it hits the dock. So this is something, again, is a repurposed piece that suits the tracker sled very well. So now let's go around to the side and we'll look at the box truss platform. So many of these components you will have seen from the past video. Clearly we had these box trusses. In this case, this box truss, the ones that are above the pontoon skis, are an odd dimension. They're an 11-foot dimension, sort of custom made. And these, you know, the two cords are, again, everything is spaced 12 inches away from each other. But the reality is that we needed to hit this 4-foot module of these brackets. So we use, again, the same component, the cast bracket that clamps against the bottom cord. That's attached to 2 angles that are bolted through that bracket that's welded to the pontoon ski. Now those who are adept at engineering will see I'm putting a weight here, or a force, in between the panel points, right, of a truss, which is not what you're supposed to do. But embedded within this this pipe is yet another pipe, a very heavy wall pipe that spans between panel points. So what you're not able to see here, if you saw X-ray vision, you would see a PVC pipe spacer, and then you would see yet another aluminum heavy pipe here. So essentially it's a trapezing the load between these 2 panel points, keeping with the idea that, again, you want to load a truss only at these panel points. So otherwise, this is a standard truss. This was made by Tyler Truss in Indiana, not far away. Okay, another issue that we have to deal with on this full-scale rendition of the tracker sled is the differential thermal movement we have in the platform, box truss platform, with the actual pontoon ski. We've talked about the aspects of the pontoon ski that are really advantageous. Its very thick wall, its ability to be recycled, its geometry, frankly. But one of the disadvantages is that this polymeric material moves quite a bit in the sun in temperature. So as an architect, I know that aluminum moves quite a bit in the sun, but the differential movement is what we're concerned about here. And if we said that this would cycle, say, through 100 degrees Fahrenheit from winter to summer, that's quite a bit of thermal movement. But the differential thermal movement would be, say, from the center of the sled, the pontoon ski would grow 1 inch longer, plus a little bit, than the aluminum box truss platform. So this, there's got to be a way in connecting these pieces and parts that we can accommodate that thermal movement. So you'll see even in these clamps, right, we have the ability to slide in this direction. And probably easiest to see in these corner blocks here that are at third points along the ski. Exactly what we're doing here. So the corner blocks are made, right, with these welded angles on each side. This is a 5-sided corner block, so we're looking in at the open side. And you can see a downturned channel, aluminum channel, right, that fits into the grooves made by those angles, with a bearing plate on top, right, with the bolts going straight through to these much stouter double angles, right, that grab onto that bracket. This will allow the pontoon ski to grow in dimension while still being absolutely securely attached to the box truss. So that is one issue we spent quite a bit of time on. You'll also see that now you have the full 20-foot width in between the box trusses on either side. And we'll we'll actually make a quick stop here at the bracket. What you'll see in the upcoming videos when we start attaching the actual solar tracker above each pontoon ski, the posts, there will be 3 posts at midpoint and that at the corner box on the end. This sort of pagoda looking bracket here in the middle is where that middle post will be situated, right? So we have these clamps, right? These threaded rods that are clamping this. We have essentially this floating aluminum plate that will allow us to adjust the XYZ, frankly, of this bracket so that we can get the actual foot of the post absolutely level with its companions. So there's adjustability in this. The plywood that you're seeing here right now, this was just installed so that the bolts and everything would remain tight throughout transportation. So let's come back on the other side here and we'll talk about some other details.